Students, so today we are going to start our next topic, that is Gauss theorem. In the last video we have discussed about the area vector and the electric flux. So today we are going to do, it's one of the applications. The name is Gauss theorem. Just see what it states. It states that total electric flux. What do you mean by total electric flux? Electric flux was the how many electric field lines are passing through the surface. Means that electric flux, we have the scalar quantity which shows or which represents that how many electric field lines are passing through a closed surface. Now Gauss theorem is also stating the same. Just see again what it states. It states that total electric flux through a closed surface enclosing a charge, means suppose I have this enclosed surface, over there inside it a charge is there, charge q is there. So it states that now due to this charge electric field lines will generate. Where the charge is, obviously electric field lines will get generated. So it states that total electric flux through a closed surface enclosing a charge, जो उसकी फ्लक्स होगी जिसकी वजह से इलेक्ट्रिक फील्ड जनरेट हुई है, जहाँ पे चार्ज इनक्लोज हुआ है, वो फ्लक्स दैट विल बी इक्वल्स टू 1/ε0 टाइम्स द चार्ज इनक्लोज्ड इन इट. जितना चार्ज इनक्लोज है डिवाइडेड बाय एप्सिलॉन और टाइम, वो किसके इक्वल होगी? टोटल इलेक्ट्रिक फ्लक्स ऑफ दैट क्लोज्ड सरफेस. And we know epsilon naught is the absolute permittivity of the free space. In the very first chapter we have discussed about it, that epsilon naught means permittivity, means how many electric field lines are permitted to pass through the surface. So just let's start the proof. Suppose if we have a closed surface S which is enclosing an electric charge Q, then according to Gauss theorem I can write this equation, that is phi is equal to Q upon epsilon naught. By definition we told this thing, total electric flux through closed surface S is given by, already we have discussed this thing, that flux is equal to Q upon epsilon naught by the Gauss theorem, and we know that flux is equal to how many electric field lines are passing through a surface. So I can write this equation also. Phi means electric flux, closed surface, that is why I have written a closed integral. E vector means number of electric field lines. ds, I have taken a small surface, and if we want to calculate the total surface I'll do the integration. So phi is equal to Q upon epsilon naught, and in that term also I have written E vector dot ds is equals to Q upon epsilon naught. Now if a closed surface encloses a charge Q, suppose I have an enclosed surface which is enclosing a charge Q, then surface integral, this is my surface integral of the electric field over the surface, closed surface, is equals to 1/epsilon times the charge enclosed. So it was all about the Gauss theorem. Its further application also we will do in the coming topics. Hope you understood this Gauss theorem. One more numerical problem I have for you related to this theorem. Just see what problem says. As per the question, a spherical Gaussian surface means that surface around which our charge is enclosed. ये मेरा क्या हो जाएगा? Gaussian surface, and inside it a charge is enclosed. A spherical Gaussian surface encloses a charge of, they have given the value as well, that is 8.85 into 10 raised to power minus 8 coulomb. They are asking to find the calculate electric flux. First thing is to calculate the electric flux. We know the formula for the flux, Q upon epsilon naught. The value of the Q is given. Epsilon naught is absolute permittivity of free space whose value is constant. I have put, and after cancelling these two terms and calculation, minus 8, this 12 will go on the numerator, it will become minus 8 plus 12, and I'll get 10 raised to power 4 Newton meter square per coulomb, which are the units of electric flux. In the second part, they are saying if radius of Gaussian surface, that surface जो मेरे चार्ज के बाहर है, वो कह रहे हैं अगर मैं सरफेस का चार्ज जो सरफेस है उसका रेडियस इंक्रीज कर दूं, चार्ज मेरे पास वही अंदर, दे आर आस्किंग इफ द रेडियस ऑफ द गशियन सरफेस इज डबल्ड, हाउ फ्लक्स विल गेट अफेक्टेड, हाउ इट विल चेंज. So there will be no effect at all on the electric flux. The reason being is that electric flux is equal to charge upon epsilon naught only. So we are not dealing with the radius of the surface, we are dealing with the charge only. If charge remains same, then there will be no effect on the electric flux which we are finding. It means it is independent of the radius of the Gaussian surface in which our charge is enclosed. As by the Gauss theorem, flux is dependent only upon the charge enclosed in it, and epsilon naught means how many electric field lines are passing through the surface. So the answer for the second question will be there will be no effect on the electric flux if the radius of the surface is increased or decreased. It is totally dependent upon the charge or the number of electric field lines passing through the given surface. So that's all about today's video session. In the next video session, I'll explain you about the proof of Gauss theorem. How can we prove the Gauss theorem and its further applications. Hope you understood the Gauss theorem and the numerical which we have discussed now. Thank you. Have a nice day.